Well, hello, chemistry students. Are we ready for another lesson in chemistry today? Well, we are going to talk about the valence bond theory, and that can be found in lesson 12 in your study guide. So if you'll open that up, let's get started. All right, lesson 12, valence bond theory. Now, we've actually kind of discussed certain aspects of this theory already. We've mentioned that when a covalent bond is formed between two atoms, that their atomic orbitals in their valence shell will overlap with one another. And without this overlapping occurring, no covalent bond can form. So the valence bond theory is going to talk about various types of overlapping of orbitals in the valence shell to form a covalent bond, okay? So in a nutshell, you can basically think that in order for a covalent bond to form, you have to take the orbital of one atom in the valence shell that has an electron in it, and the orbital of another atom that has a electron in it, both in the valence shell, and these two are going to form a covalent bond, and therefore they're going to come together and the orbitals will overlap with one another. And once that overlapping occurs, the electrons now in those overlapped orbitals are going to be shared between the two different atoms, and that's going to form that covalent bond. Now we indicate this overlapping when we draw a Lewis structure and we put two dots in between the two atoms. And the two dots in between the two atoms represents the overlapping of the orbitals to form that covalent bond, okay? Now, for the rest of this lesson, all we're going to do is focus on the different types of overlaps that can occur to create covalent bonds. The first one is known as a sigma bond. And the way I like to look at a sigma bond is just basically you're going to take two orbitals and they're going to overlap head to head from one another. So here comes one, here comes the other, and bang, overlap, okay? Now, this can take place with an s orbital. So here's our s orbital, remember it's spherical, and another s orbital, and they could just head to head overlap like so, and therefore share a pair of electrons and create a covalent bond. Or you can have an s and a p orbital come together, overlap head to head to form a sigma bond. Or you can have one p orbital and another p orbital, and they come together and overlap head to head. And this is kind of represented by this picture here in your notes, where you have two p orbitals, one in red and the other one in yellow, and they're from two different atoms in the valence shell, and they're just going to come together and form this overlapping that takes place and forming the covalent bond. And at that point, the covalent bond is formed with the overlapping, and the two nuclei of these two different atoms are attracted to both electrons and therefore share both electrons in forming the covalent bond, okay? So that's a sigma bond. Now, what you're gonna find is that all single bonds, anytime you see a single bond represented in like a Lewis structure or some model, all single bonds are head-to-head overlapping or forming sigma bonds, okay? Now, another type of orbital overlapping are known as pi bonds. Now, a pi bond can only occur with p orbitals. That's important. Only p orbitals can form pi bonds. And essentially what's happening here is two p orbitals that are parallel to one another. Okay, so they can either be parallel this way, right, along the x-axis, parallel along the y-axis, or even parallel along the z-axis. Either way, these orbitals p orbitals have to be parallel to one another. And essentially what they're going to do is, instead of head-to-head overlapping, they're actually going to do side-by-side overlapping, as indicated in this picture that we see here, where again we have a red p orbital and a yellow p orbital. They're both parallel, and they're going to form this overlapping on the sides and not head to head. And they can overlap in two different places as indicated here. And so we could actually have a pair of electrons up here, which is indicated in the model, or down below in that overlap. Okay, so either lobes can essentially have those pair of electrons that are being shared in a covalent bond. Okay, now some more information. We only find pi bonding occurring in double bonds or in triple bonds. And we'll look at this a little bit more in just a moment, but we said that a single bond only has a sigma bond, head-to-head overlapping. But a double bond is going to contain both a sigma, head-to-head overlapping, and one pi bond, okay, side-by-side overlapping. And so that's essentially what a double bond is. One covalent bond is going to be sigma, and the other covalent bond is going to be a pi. So we have a sigma, pi to create a double bond. In a triple bond, we're actually going to have a sigma bond, we're going to have a pi bond, and then we're going to have a second pi bond. Okay, so the way I like to look at it is a triple bond is a sigma, pi, and then pi, right? Sigma, pi, pi. And so you have head-to-head overlapping, you have a side-by-side overlapping of p orbitals, and then you have another side-by-side overlapping of different p orbitals that occurs along that z-axis, so the y and then the z-axis, okay, forming those pi bonds, okay? Let me give you a drawing example of this. Let's say that we have let's clear this, we have two carbon atoms, and those two carbon atoms are going to form a double bond, okay? So I'm going to represent one carbon atom with its symbol C, and a second carbon atom, ooh, that's really big. Let me shrink that down, okay? This second carbon atom is represented by its C, okay? So first of all, if we're going to form a double bond, we need to have a sigma bond formed between these two carbon atoms. And that sigma bond is going to be created by an overlap of orbitals, okay, like so. And there's our overlap of two orbitals head to head to form a sigma. And we'll actually use that sigma representing, and we'll put a 1 to represent one sigma bond. But to form a double bond, we also have to form one pi bond. And so what we're going to do is have a p orbital on this carbon atom, and we'll call this the py. And then the other carbon atom also has to have a py then. And these both have an electron in it. And so what's going to happen is they're going to form an overlap. And that's what I'm creating. I know it's a little crude drawing, but essentially you're going to have an overlap. And as a result of that overlap, I'm going to erase that electron and that electron. And so as a result, you're going to get two electrons being shared between these two p orbitals as they overlap. And really, there's also an overlapping here, remember? And so those two electrons could be down here as much as up there, okay? So essentially, we have our, and we'll call this by its appropriate symbol, a pi bond, and there's one of them, okay? So again, you're going to have a sigma bond, the head-to-head of overlap, and a pi bond, which is side-by-side overlapping. And that's going to result in a double bond, okay? All right, so to summarize everything, okay? Because this is what I think you need to walk away with in this lesson, is to understand that there are two types of overlapping that can occur. A sigma bond, which is head-to-head overlapping. We only find sigma bonds single bonds are only made up of sigma bonding, okay? So anytime you see a single bond, you can think of that's also a head-to-head overlapping that's occurring, and therefore a sigma bond. And a double bond, as we just mentioned, contains a sigma and a pi bond. And a triple bond is a sigma pi pi. So 2 pi bonds and 1 sigma bond, okay? So what I'm gonna do is we're gonna use real Lewis diagram here. This is the carbonate ion, CO3 2 minus. And what I have is already the resonance structures done for this carbonate ion. And what we need to be able to do is look at the bonds that are occurring, the covalent bonds that are occurring, and determine if it's a pi bond or if it's a sigma bond, okay? Or how many pi or sigma bonds. So we only need to look at one of the resonance structures to do this. So I'm just going to use this first one here. And I have a single bond here. So that single bond must be a sigma bond, right? And I also have another single bond right here. And that also has to be a sigma bond, okay? So far, I actually have 2 sigma bonds in this structure, both at these, where these single bonds are at. Now we have a double bond. Well, what's the double bond made up of? Well, the double bond is made up of 1 sigma and 1 pi bond, okay? So what we would say for this structure is that we have, and this is for the AP test or IB test, is that we have 3 sigma bonds and 1 pi bond total for this structure, all right? Regardless of the other resonance structures, because they're all the same, we only have 3 sigma and 1 pi bond for this structure, okay? And that's what we would do. We would have to first draw the Lewis structure, and then we would look at the single bonds, and a single bond would represent a pi or a sigma bond, and then a double bond would represent a sigma and a pi, and then if there was a triple bond, it would represent 1 sigma and 2 pi bonds, okay? And essentially all we need to do is identify where those sigma and pi bonds are and how many total there are in the structure of the molecule. And that's it. And that's all there is to it. And that's the basics of the valence bond theory. And essentially that's all you really need to know at this juncture, okay? So that's it for this lesson. So I'm gonna sign off, but you need to go back and study this and make sure you understand really well what a pi and a sigma bond is and the difference between the two, okay? So that is it. We'll see you later.